projects. In this video, we are going to explain about the project which is tackling depression detection with deep learning, a hybrid model. Before getting into the execution of the project, let me give you an overview. Depression is a widespread mental health ailment impacting millions globally, presents challenges in detection owing to the subjective manifestation of symptoms and societal stigma surrounding help seeking behavior. This combination of factors underscores the pressing need for more objective and accessible detection methods. Deep learning, a subset of artificial intelligence, has shown remarkable success in various fields, including healthcare. A deep learning hybrid model is proposed in the project that integrates multiple data modalities text to enhance the accuracy and robustness of depression detection. By leveraging diverse sources of information, we aim to capture a more comprehensive understanding of an individual's mental state. The methodology relies on collecting transcripts from various sources and pre-processing them to remove non-textual elements and standardize formatting. Feature extraction techniques including word embeddings and sentiment analysis are employed to capture linguistic nuances associated with the depression. A deep learning model, which is pre-trained on a large corpus and fine-tuned on the transcript data, is developed and trained using appropriate algorithms and evaluation metrics, facilitating its deployment as a depression detection tool after thorough validation and assessment of its performance. By developing a reliable and efficient depression detection system, the project seeks to facilitate early intervention and personalized treatment strategies, ultimately improving outcomes for individuals suffering from depression. Additionally, such a model could elevate the burden on the healthcare providers and reduce the stigma associated with mental disorders. To implement this project, we need software and hardware requirements. And the software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. So now we will know what are the algorithms used for detecting the depression. The first algorithm is TextCNN. CNN refers to convolutional neural network. TextCNN, it is a convolutional neural network architecture specifically designed for processing textual data. It applies convolutional filters over word embeddings to capture local patterns and dependencies within the text. Text CNNs are effective in analyzing textual data, making them suitable for identifying linguistic cues associated with the depression in transcripts. Coming to the next algorithm, which is BiLSTM, which refers to bidirectional long short-term memory. It is a type of recurrent neural network that processes the input sequences in both forward and backward directions. It utilizes long short-term memory units to capture temporal dependencies and context. BiLSTM networks excel in model sequential data, allowing them to capture the temporal dynamics present in the transcript data and identify patterns indicative of depression symptoms. Coming to the next algorithm, which is hybrid BiLSTM. This model integrates BiLSTM networks with other architectures to enhance performance. It combines the strengths of multiple models to improve depression detection accuracy and robustness. Hybrid BiLSTM models leverage the complementary strengths of different architectures and data sources to improve the overall performance of the depression detection system. Coming to LSTM with GRU, which refers to long short-term memory with the gated recurrent unit, it combines LSTM and GRU architectures, both of which are variants of RNNs designed to address the vanishing gradient problem. LSTM focuses on capturing long-term dependencies while GRU offers computational efficiency. Combining LSTM and GRU architectures enhances the model's ability to capture diverse temporal patterns present in transcript data, thus improving depression detection performance. Coming to hybrid LSTM, it integrates LSTM networks with other architectures to improve depression detection performance. It combines LSTM strengths in capturing sequential dependencies with the other models to extract meaningful features from transcripts. Hybrid LSTM leverages the strength of LSTM networks and other models to enhance depression detection systems accuracy and reliability. The last algorithm is LSTM, which is long short-term memory. It is a type of recurrent neural network architecture designed to address the vanishing gradient problem by maintaining long-term dependencies in sequential data. It utilizes memory cells to capture context over long sequences. It is well suited for analyzing sequential patterns in the transcript data and identifying linguistic cues indicative of depression. So now we will execute the project. To execute it, first we have to open the code folder which contains source code files. So I'm opening the code folder. This is the code folder of the project. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in HTML templates. In this folder, we have the dataset, and in this dataset, we have messages related to depressed and non-depressed content. Along with that, we have the labels which are 0 and 1. 0 refers to non-depressed message. 1 refers to depressed message. I'll open one more data set. Here in the augmented speech transcripts, here also we have depressed and non-depressed messages. Along with that, we have labels to it. Here also, label 0 refers to non-depressed and 1 refers to depressed. And we use both of these data sets for training all the algorithms in the project. And both of the data sets are augmented speech transcripts and the transcripts data set. Now we'll get back to the code folder. These are the model files which contain the algorithm information and that will be loaded into the project code during runtime. This is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the signup.db file. This file is a database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. This will change current directory to the code folder's path. Here we can observe that current directory is changed to the code folder's path. Now we need to compile app.py file. So type the command python space app.py and now click on enter. This will compile app.py file and it will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flash framework will host the application locally at the default address, which is the local host, and the port, unless configured differently. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. So here we need to paste the link and then click on enter. This is the web page of the project, which is developed using Flash framework. To execute it, first we need to sign up if you are new users. So click on sign up and enter all the registration details if we are registering newly. I have already registered and I have an account in it, so I'll directly sign in. So click on sign in now. Here we need to provide the username and the password to log in. And now click on login. We have logged in successfully and redirected to prediction page. So here we can see a text box wherein we need to give the input message. Based on the provided input message, the application will detect whether the transcript has depressed content or not. I have already told you that in this Excel sheet, we have some of the test cases using which we'll be doing the depression detection. So I'll be copying the first test case. I'm pasting it. Now click on predict. So here, based on the provided text, we got the prediction as the transcript is not depressed content. We can understand that from this content, which is a transcript, there is no depressed content in it. And the topic for the paragraph is most dependent upon these words. Now we will try giving the other messages. Click on home. I have given the message. Click on predict. So here, based on the information provided, we got the prediction as the transcript is depressed content, which is this particular content has the depression message. Now we will try giving the other message. Click on home. I'm entering the message. Click on predict. So here we got the prediction that the transcript is non-depressed content, which means that this particular message has no depression. It portrays no depression. And the topic for the paragraph is most dependent upon these words. Now we will try giving some more messages. Click on home. I have entered the message here. Click on predict. Based on the provided content, the application has predicted as the transcript is depressed content, which means that this particular message portrays depression. And the topic for the paragraph is most dependent upon these words. Now we will try giving some more messages. Click on home. I'm entering the text here. Click on predict. Here, for the given message, we got the prediction that the transcript is depressed content. And the topic for the paragraph is most dependent upon these words. We'll give one more message. Click on home. I'm pasting the message. Now click on predict. Here we got the prediction as the transcript is non-depressed content, which means that this particular message do not portray the depressed content. And the topic for the paragraph is most dependent upon these words. Now click on sign out. In this way, just by giving messages to the system, it will detect whether the transcript has depressed content or not. In conclusion, the deployment of the LSTM GRU signifies a strategic choice based on its strong performance in capturing nuance patterns within the transcript data. This decision underscores the project's commitment to deploying an effective and reliable depression detection system capable of identifying individuals at risk and enabling timely interventions. By leveraging advanced deep learning techniques, the project aims to make meaningful strides towards improved mental health outcomes and reducing the stigma associated with depression.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.